Welcome back. Today we are looking at one of the most important topics in organic chemistry, electrophilic addition to alkenes. When an alkane reacts with a hydrogen halide like HBr or HCl, we need to know where the hydrogen ends up. Markovnikov's rule gives us the answer. It says, the hydrogen atom adds to the carbon that already has more hydrogen atoms attached. In other words, the rich get richer. The carbon with more HS gets the new H. We'll see why in just a moment. Here's the general reaction. An alkane plus HX gives us a haloalkane. Let's look at propene with HBr. Following Markovnikov's rule, the hydrogen goes to the end carbon, which has two hydrogens already, and the bromine goes to the middle carbon. That gives us 2-bromopropane as the major product. But notice, we also get a minor product, 1-bromopropane. That's the anti-Markovnikov product. So why do we get a mixture? And why is one major and the other minor? That's where carbocation stability comes in. The key to understanding the product ratio is carbocation stability. A carbocation is a carbon with only 6 electrons. It's electron deficient and unstable. But alkyl groups like CH or CH can stabilize it by pushing electrons toward the positive charge. This is called the inductive effect and hyperconjugation. The more alkyl groups attached, the more stable the carbocation. So the stability order is tertiary, secondary, primary, methyl, with methyl being so unstable it rarely forms. Now, in our reaction, the major product, 2-bromopropane, comes from a secondary carbocation. The minor product comes from a primary carbocation. Since secondary is more stable, it's the major product. Let's walk through the mechanism for the major product, the Markovnikov pathway. Step 1. Initiation, slow step. The pi bond of propene attacks the hydrogen of HBr. The hydrogen adds to the end carbon, and the bromine takes the electron pair, leaving as bromide ion. This forms a secondary carbocation on the middle carbon. This is the slower, rate-determining step. Step 2. Nucleophilic attack. Fast step. Now the bromide ion, which is electron-rich, attacks the carbocation, which is electron-poor. That forms our final product, 2-bromopropane, the Markovnikov major product. Now for the minor product, the anti-Markovnikov pathway. In this case, the hydrogen adds to the middle carbon instead. That forms a primary carbocation on the end carbon. Primary carbocations are much less stable, so this pathway is unfavorable. Then, in the fast step, the bromide ion attacks that primary carbocation, giving us 1-bromopropane as the minor product. So the ratio is controlled entirely by which carbocation forms. The more stable secondary gives the major product. Let's quickly recap. Markovnikov's rule. The hydrogen adds to the carbon with more hydrogens. The mechanism is a two-step electrophilic addition, slow protonation followed by fast nucleophilic attack. And most importantly, carbocation stability controls the product ratio. More stable carbocation equals major product. Now here's a practice question for you. Predict the major product when 1-butene, CH equals CH, reacts with HCl. Pause the video, try it yourself, and I'll give you the answer in a moment. The answer is 2-chlorobutane, because the hydrogen adds to the terminal carbon, giving a secondary carbocation, which is more stable. If you got that, well done. If not, just rewatch the carbocation stability section. Thanks for watching, and don't forget to like, subscribe, and hit that bell for more chemistry content. See you next time.